All right, there's another feature on rational functions known as a removable discontinuity. Sometimes that's referred to as a hole in the graph. Anyhow, a hole happens in the graph when you've got a factor in the numerator and the denominator, and it cancels out completely from the denominator of the function. So for example, we've got this function here, f of x equals x squared plus 3x minus 18 over x minus 3. Now, if I were to factor the numerator, since it is quadratic, it would factor into x plus 6 times x minus 3. So you'll notice in that one that x minus 3 is common to both the numerator and the denominator. So that means those factors would cancel out. And that would leave me with just f of x equals x plus 6. However, this function is still undefined at x equals 3 because an x value of 3 would still make the denominator of the original function that was given equal 0, which is not allowed. So that means there's going to be a hole in this graph when x is equal to 3. So I'm going to start by writing down the x value there. It is helpful also to know the y value of the hole, the exact location of where it would be along the curve. So to find the y value, we would take the x value for the hole and put it into what's left of the function there. So I'd find f of 3, putting in 3 in place of x, that would be 3 plus 6. And 3 plus 6, of course, is 9. So my hole would occur at 3, 9. Now to see a second one like that, this one's not on your notes, but I figured seeing a second one would probably be helpful for you. So here we've got a new function. It's called g of x. It is x plus 3 over x squared minus x minus 12. The denominator of this one is quadratic, so I'm going to start by factoring that denominator to see if there are any common factors with the numerator. So to factor that, I'm looking for things that will multiply to make negative 12 and add to make a negative 1. So that would be a minus 4 and a plus 3. My 4 kind of looked like a 9 there. I'm going to fix it. There we go. Okay, so now that I've got it factored, I can see that there is a common factor, this x plus 3. That leaves nothing in the numerator. Now, when everything cancels from the denominator, you can just not write the denominator and it's not a big deal. But when everything cancels in the numerator, you still have to write a numerator because what's left over is in the bottom. And it's important that it stays there in the bottom. So in that numerator, I've got a 1 left over. You can also think of that as anytime you divide something by itself, you get 1 as a result. So the 1 is what's left there. All right, so my reduced function here is g of x is equal to 1 over x minus 4. The value of x that would make the factor that canceled out equal 0, I can find that by actually taking that factor and setting it equal to 0, just in case it's not quite so obvious. And then I can use algebra to solve it. So I'd have to say for this function, but x is still undefined at negative 3. So I'm going to say x cannot equal negative 3. Now that negative 3 is the x value of the hole. So I'm going to go ahead and write that down as my x value, negative 3. I also need the y value of the hole, so I know where it falls in line with the curve. So I'm going to take my reduced function here, even though it says x is not allowed to be negative 3, I'm going to put negative 3 in place of x. And then simplify. So on top there's just a 1, there's nothing I can do to simplify that. On the bottom it says negative 3 minus 4, which is negative 7. And when you have a fraction and you end up with a negative in the denominator, it's proper to rewrite it so that that negative is either in front of the fraction or in the numerator. You can just slide it to either of those locations, it doesn't matter. So my y value for my hole would be a negative 1/7. Okay, now there are 2 guided practice problems on your notes. I want you to do those and then answer the questions on the Google form that go along with them.